Hey, how's it going?
Hello, can you hear me?
Yeah, I can hear you.
Alrighty, great.
Hey, have you used this platform before?
I'm sorry?
Have you used this platform before?
Yes.
Okay, cool. So you kind of know how it works. Um, so what language do you want to use?
C++, that's okay.
Yep. Oh, you already switched it. Cool. Um, so I saw that you were a junior engineer, roughly.
Yeah, less than 1 year full-time experience.
Okay, so I'm gonna start you out with this, and I want you to just implement the square root function.
Um, so we're returning, okay, so obviously, we don't want to use any library functions, right?
Right.
Okay. Um, so there's lots of different ways that you can find square roots in different languages. You can use assembly, you can use different approximation methods. Unfortunately, I don't have them all memorized. I only know one, the Babylonian method. And I also know how to find other roots as well. But let's just start off with the Babylonian method.
What is that?
It's an approximation. So, like, let's say we had the square root of 100, right?
Hmm.
That's easy. It's just 10, right? But what if it was like something like 47, right? We need to approximate that. So with
Right.
100, what we do is we take 100, we take our value, and then we take the number 1, and then we try and make 100 smaller and 1 bigger until such time that it becomes less than some epsilon, where epsilon is some error value. So we can get it within some error value.
Right.
Okay.
Okay.
Are
That
you,
makes
are
sense.
you familiar with the method, or should I just?
Uh, I've never heard it called that, but I think it's very familiar to what I expect. So,
Um, it,
uh,
you
that
might.
works for me.
Okay, you might know it by Newtonian method, maybe.
Yeah, I've heard that.
Okay, great. So let's see. So we'll take a is equal to value, b is equal to number 1 for now, and then our error epsilon, which we'll do. How about zero point zero 0.01?
How about 6 digits,
Sure. So do you mean
six
like?
decimals? Yeah.
Okay, great. So let's see. While the difference between A and B is greater than E, we're going to try and uh, make A smaller and make B bigger. And then once we're done, we'll just return A or B because they'll be close enough.
Okay.
So let's take a look at the example 101. So what we want to do is take 100, add it to 1, that's 101, divide by 2, that's 50.5. So how does this help us? Well, I just made A lot smaller, right? I cut it in half.
Right.
So let's see. That is A is equal to A plus B divided by 2. Okay, so now that's 50.5. And now we will set, let's see, B was 1, so we'll set B equal to the original value, which was 100, divided by 50.5. So I'm gonna, if it's all right with you, I'll pull out a calculator so I can prove that this is working.
Sure.
Okay, so let's see. If I do 100 divided by 50.5, I end up with 1.98 approximately, right? So we're
Sure.
getting closer. We're gonna be done in like 3 iterations. So just let's just do it 3 more times. So let's see. So now we're gonna do 50.5 plus 1.98. Divide that by 2. Now we have 26.24. So I've just divided it in 2 again, right?
Yeah.
6.4. Okay, so now I'll do 100 divided by 2624. And that's like around 4. It's like 3.81. We're getting closer, and we're going to be done in 2 more iterations. So let's see, 26.24 plus 3.81. Divide that by 2. 15.025. Almost done. This is 6.66. Okay, so we're almost there. I think in one more iteration, we'll get not we won't get in between 6 digits, but we'll get close enough to where I can prove that this is working.
Sure.
So let's just do that one more time. Plus 15.025 plus 6.66. Sorry, I don't have a physical calculator, so I'm using the one on my computer.
Oh, that's fine.
Okay, so this becomes 10.845. And 100 divided by 10.845 is 9.222. So I won't do it anymore, but I think it's very obvious that we're approaching, some limiting value, which is 10. I might need to do a couple more iterations, but I think it's obvious now.
Right, and when you run it, we'll be able to see it. So.
Sure. So do you want to run it now or?
Yeah, just to see if it comes up with it.
Okay, so let's do 100, which is easy. We'll get a value close to 10, and then let's do something like 47. Okay, so if that looks good to you, I'll go ahead and run it.
What?
I said if it's all right with you, I'll go ahead and run this now.
Sure.
Square root. I think we need to. Here we go. So that's 10, and I'm just going to check my calculator, and yep, the square root of 47 is 6.85565.
How about 2?
Let's see.
I've done this question so many times. I already know what the square root of 2 is now.
Okay. Yeah, that was.
So when does this fail?
Let's see. Maybe if we have negative numbers. Well, you shouldn't be able to. You don't want to take the square root of a negative number because it'll be imaginary. So
Right.
you can deal with it however you want. You could maybe make some imaginary object, or you could just make it absolute value. So,
Yeah.
you know,
Let's just throw an error.
okay. Going to have to remember might get my Java wires crossed here. Oh, do you want to do a try catch, or do you want to just return like -1 or something?
Well, I would just throw, right?
Okay. Oh, I'm really gonna get my Java wires crossed. What's that called? Number exception?
I don't know. I just usually just throw exception or throw a comment, right? Um. Let's try. Also, let's try 0.25.
Okay. That is double. Oh, so 0.25 is
Right. You'll have to switch it to double as input.
sure. Let's switch that up. Okay, so I'm pretty sure 0.25 squared is not excuse me, square root. Yeah, it should be 0.5.
Yeah.
So let's see what happened here. It shouldn't be because of this, I don't believe.
Well, look at B, right? You're
Uh,
trying to find a value under 1, right?
right. Okay, so what's happening is we're doing 0.25 minus 1. We end up with a negative number.
Mhm.
So instead of defaulting to 1, we want it to be smaller. So maybe I can just default to, I don't know, maybe value divided by some constant. Like, let's see.
Why not just set it to 0?
So a minus b. Well, let's see, we're not dividing by b, so I think that should be fine. We're not dividing by b. 8 plus 100 divided by 2 becomes 50. I'm not sure. I've actually never done that before. Can I run the code and see what happens?
Yeah. Yeah.
Okay, yeah, so it
It
fails.
breaks it a little bit. Yeah.
So, I don't know. What maybe not point.
So do you notice a pattern with a square root underneath one?
Um, hmm. It's being divided. Well, for two, the only pattern I see right now is under one you said 0.25 is well 0.25 becomes 0.5.
Right.
Hmm. Well, I mean 0.3 doesn't become 0.6, so
Right, but it does become something greater than point 0.3, right?
oh right, okay. So in this case, this algorithm is trying to make a smaller and b larger, but we don't actually want to make it smaller. It's going to break, right?
Yeah.
So let's see. For numbers smaller than 1, if I had 0.25 and I did minus some very small number, I would end up making 0.25 smaller. I don't know. Maybe we can do some multiplication to get that to work.
Well, let's think about it this way. Above 1, you want to find a number less than, right? And below,
Right.
you want to find a number greater than, right?
Right.
So basically, you just invert the logic, right?
Okay. So maybe I'll say if the number is less than 1, then instead, well, I'm not sure if I can just change these to multiplications.
Right. Hey, so I'm gonna move on to my second question.
Yeah,
Um,
that's fine.
so I'm gonna give you a point class, or just these could be tuples or pairs. Um, actually, let's just do that, right? And finally, someone who programs in my language. So let's say these will be like -1, 1, 13, 2, 0, 1, 1, and so on, right? And then I'm going to give you a point class, which is parent, origin, which will be the center of the graph. So let's make it 1, 1, right?
Okay.
And then I'm going to give you k is equal to like 2. What I want you to do is find the k closest points around the origin based on distance. So in this case, it could be like 2, 0. Yeah. So 2, 0 and 1, 1, right?
Okay. Okay. So let's see. What I could do is iterate through this points array, take note of each uh, distance value, right?
Right.
Maybe store those in a hash map. So let's see. We'll just make up some imaginary numbers. I don't know what that actual distance is, but let's say the distance. Let's say it's 1 away. So we can determine that. Okay, well here are the 2 points, and those are the 2 closest. If k was 3, then I might be able to do something like this. Get those 2, then move on to the next one.
Sure.
So let's see. Store by key. For now, I'm just going to use an ordered map. I think we might be able to get away with using a bucket afterwards, but let's just do an ordered map for now.
Okay.
Let's see. I guess you want to return a vector of points as well.
Yeah.
Okay. About k closest points, and I'll take in this input. So let's make an ordered map for now.
So you want to pass in all three, right? K, origin, and points.
I'm sorry?
So you want to pass in all three, right? So points, origin, and K.
Oh, right. Okay, there's the vector of points. Okay. So what does our hash map look like? Well, it's going to be int key for distance, and it will have one or more points.
Right.
Map. Iterate through points. I want to use auto. Sure. Auto point in each point. Now we can do point dot first and second to get x, and we have our origin. So let's just do distance formula. Let's see, if x is equal to point dot first, y is equal to point dot second. Actually make this x2 and y2. And let's do this actually to make things easier. We're going to be using it a lot. So origin first and second. Now distance formula is, I'm going to have to think back to my school days, x2 minus y2. Hold on. Forgot my distance formula. 2 minus x squared, maybe? Y2 minus y, and then square rooted. I just don't know if these two are squared.
Which one? Oh, yeah, they're squared, and then the square root of that.
Okay, so they are both squared. Should we use our square root function, or can we do math?
Just use the built-in one.
Okay, and I think that's in C math, so it should be something like how squared, and then that whole thing square rooted. Well, this is just going to use our square root function, but I'm pretty sure there's no math dot if we're using math. So
well, that's fine. We'll just change this back to. Oh, you already changed it. Never mind.
Okay. So now let's see what kind of what should we do? Map dot distance push back this new point that we just created, right? Now we have a hash map, or in this case an ordered map, which is a B tree of key's distance and all the points associated with that key. Okay, so now let's do something like this. While k is greater than 0, start printing out.
I got a question.
Yeah.
What happens when the distance is the same?
That it will store. Well, that's the. I mean, do we consider that a very close point?
Oh, I see. You have a vector, so you just push them. Never mind.
Okay.
That works then.
Okay, so while k is greater than 0, so let's say k is 1, we'll get 1 point, and then we'll print this out. So walk through our map. Oh, actually, never mind. Let's actually do it this way. Walk through the map, then walk through the iterator. Value, and the value is a vector, so walk through that vector. Then we'll decrement k as we're walking through the vector. You want to return a vector, so let's make a result set as we're walking through, I'm going to get rid of this. As we're walking through, we will do we'll push one at a time. We'll decrement k, and if once k becomes 0, we can just return the result set. Let me actually change this to result set. Or maybe we won't walk through it at all, and then we'll just return an empty result set. Okay, so that looks okay. Does that look okay with you?
Yeah, let me just look through it. Yeah, it looks about right. We could probably run it and test it.
Okay, before we do that, we're gonna have to move our main down, and I guess I'll just use your example. And we might need to include utility and possibly map.
And vector.
Okay. Let's just comment this out for now. Our vector points. Oh, you actually have the whole thing copied. Let me just.
Well, that probably won't work fully, but.
Okay, we need to. Let's see, vector pair of points. Yeah, so this isn't already a pair. Well, actually, I'm not sure if you can instantiate pairs as that. I've never done it like that before.
I mean, you could probably just use make pair, right?
Yeah, that should work. It's a lot of make pairs though, but that's okay. Let's do this. Calculate result set. K closest points. We need points, origin, and K, and then just print each point. Yeah. Each point's going to be a pair. So how about we do it like this? Hold on first. Oh, actually. Okay. Make pair, I think, works like this. If I'm mistaken. It's not the most glamorous, but we can do this just for this example. Okay, that looks good. There might be some bugs, so we're gonna have to run it. Okay, let's take a look. Oh, I need CMath. And let me go ahead and comment out our square root code. Got changes to x1 and y1. Anything else? Decomposition cannot be declared. Oh well, I don't have map made properly. So let's call this. Oh, let's just call this memo for now. Okay, that looks all right. Argument 2 is invalid. A vector of pairs. We should be allowed to have a vector of pairs.
I mean, you could probably just do this, right?
Oh, hold on.
Or not that, but.
I'm sorry?
like the vector pair should be something like this, right? Ideally.
Um, yeah, I guess so. I, hmm, okay. I mean, I feel like I've done it before with just curly braces, but yeah, that's fine. Let's invalid double and double. How?
Yeah,
Um,
your distances should be double.
okay, let's make this a double. This a double as well. We are square rooting, so yeah, that looks good. I shouldn't have to make the points double though. I think it'll be okay. Here we go. IT second. No, it should be IT second. Increment. We have an iterator. IT second is a vector. Increment points through the vector, and then push the whole point onto the result set, which is a vector of pairs. Okay, let's see. Let me just change these doubles for now. Should be able to cast without problem. Non-pointer type. No, I'm pretty sure it uses no, or not. Invalid operator.
Oh, look right here. Two Y2s.
Oh, okay. X1 and Y1, X2 and X1, Y2 and Y1. Okay. This one I'm still confused about. I swear the other day I did arrow though. Okay. So let's see. That is the correct answer. Uh, given what you gave. From your example, I mean.
Right. So how can we improve this?
How can I prove it?
Improve it, yeah.
Oh, improve it. Okay. Well, let's see. The time complexity of an ordered map is log n. So right now, this looks like an n log n algorithm, right? For each point, we're keeping them sorted. I don't think we actually need to keep them sorted. We might be able to use a bucket. So let's see.
I mean, that's what you're already doing, right?
Sort of, but what I can do is map points to distance as well as distance to points.
Right.
What,
What what's I'll give you a small hint. What if we started thinking about an nlog k implementation?
we could maybe use a heap, but let's see. Okay. So what I could do is calculate this distance. Hold on, let's look at the example again. A max heap where we keep points sorted based on their distance, and we're only interested in the first 2 points for now. So let's see. I would take a look at 0 and -1. Oh, that's interesting. Oh, I thought the origin was 0, 0 for a second. Okay.
No.
So I'll take a look at 0 and -1, calculate this distance from 1 and 1. I'll put, how about I just push those first 2 points on the heap, and then once I get to 2, 0, I'll realize that its distance is smaller than I guess the top of the heap, arguably.
Yeah.
And then we'll just push that on. Oh, we'll pop, and then we'll push it on.
Sure.
Okay. Let's see. So what I need is a priority queue of points. And we're going to have to change it from a max heap into a min heap. So I'll have to do vector of points. Oh, no, sorry. Vector of pair. Getting my points and pairs mixed up. Priority queue of pairs. Vector of pairs. And a greater. No, a lower. Also pairs. I think we're gonna need a custom operator. I'm not sure if I remember how to overload the priority queues operator.
Just the lambda function.
I'm sorry?
Just the lambda function.
Lambda? Yeah, I don't remember the lambda. Okay, hold on. Since we're kind of crunching time here, can I just do that later?
Yeah.
Now let's just assume that this priority queue is working the way we're intending it to working, and we obviously want it to be of size k. Lower, more. Okay. So now, as we iterate through these points, instead of storing anything in distance, let's just do the old distance. Current min. Sure. Min x is going to be q. Priority queues use top. And their pairs. So first, by q dot top second, calculate min distance. So we are calculating it using min x minus x1 and min y minus y1. Excuse me. So if the new distance is less than, what if it's less than, what if it's the same? I guess we can just ignore it, right? We don't care if, like if we have 3 points and k is 2, and points 2 and 3 are the same distance, I guess we just don't care, right?
Yeah.
Okay, so we'll do q dot pop. We'll make a new pair. Using that new x. Oh, actually, no, we already have points. It's a new point, that's right. So pop, and then push that new point on.
So is your comparator going to say that, hey, I want to recalculate the distance every time?
Yeah, that looks like what it's doing. Square root and pow are a little bit expensive. We could probably optimize that further.
Yeah.
Possibly use instead of foregoing a map entirely, we might be able to use the map to have distance to pairs. But let me come back to that in a second.
Sure.
So let's see, if distance is less than max distance, well, what if queue size is greater than 3? Excuse me, greater than k. Then you can pop. Otherwise, you don't need to pop. You can just push.
Right.
Okay. So that looks good. Instead of pushing this onto the memo, look a little cleaner. So now we just need to get all the points from the queue. We know the queue is already sized. while queue is not empty, back that new queue, and then pop. Okay, and yeah, the rest of our code should work, assuming queue works. So, we are recalculating distance every time for the queue. Let's see if we can optimize that further.
Um, I think I am happy with this, so we should stop.
Okay.
I do like the typical 45-minute interview where 35 minutes is tech. Um, and then I get into your feedback if you want to hear it, and then give you a chance to ask any questions and discuss any of the feedback.
Okay.
Do you
Oh
want to
well,
hear it or?
yeah, absolutely. Before you do that though, I do just want to mention, and you already mentioned it, I think, the time complexity of this is n log k, and the size is O of k.
Sure.
Unless we wanted to use this hash map for other stuff, then the size could go up to O of n.
Yeah. Cool. So I guess for me and my feedback, uh, I've never seen someone solve the square root like that. I thought you were gonna do a binary search.
I have,
It's very similar, but it's not. Um, but it's a cool implementation, and clearly it works. So you'd have to figure out how it works with the underneath one. But
yeah,
um,
I've done the binary search method before, but I think this actually has better time complexity. I think this is actually log of n, but I'm not
okay,
100% sure. I'm not like super into numerical analysis. I just
yeah,
read that in passing one time.
yeah,
With that said, the whole less than one thing, I think I just remembered a way to fix it, so I'll definitely take a look at this afterwards.
sure,
It's in regards to, because this algorithm, you can actually use it to find any root. Like you can find the 10th root. All you
yeah.
need to do is multiply a by uh, some n minus or something. So I
Oh.
think that might have been the issue. But I'm sorry. Go, please continue.
No, I liked it. It was a good implementation for sure, and I'm gonna have to look into this myself because I've never done that. Um, I've always done it with the binary search, but if it's better, it'd be neat to know it. Anyway, couple of things I've seen throughout is one, you don't really check for edge cases at all. Like one thing that I kind of look for in the beginning is like, hey, this is the question. I understand it. Here's what the input is. Output. Some edge cases. Here's the potential solutions I would use. Here's what I'm going to use because of X. All right, let's code. You're just kind of missing the edge cases and the proper testing of those edge cases. Um, One other thing I would note would be it'd be nice to have a little bit better, cleaner code, like better variable names and stuff. Like instead of A, B, and E, just uh, like left and right or low and high and so on, right?
Right.
One thing you got to remember is if you go to a hiring committee, uh, several weeks down the road, you have to assume that people will be looking at your code that did not interview you, and you want them to be able to read it. So it does look like it follows the style guide some pretty well, just not the variable naming. Um, so for k nearest neighbors, k closest points, I would try to step back and practice lambda functions and functions in general in C++. Also exception handling is one thing I would look at as well, because you were mixing up Java and C++, and yeah, I would just take a look at how exceptions are done in C++. Um, yeah, I know I'm jumping all over the place. So anyway, back to K closest points. Um, I'd look at lambda functions or std functions, see how they work. Um, And then down here, this is a little weird. Uh, you're checking to see if the distance is less than min distance. What I think you're wanting to do is max distance, but um, I would have put the size is greater than k above it instead of below and said, hey, it's at the first k. And then everything after check that the distance is less than, not the other way around.
Okay.
Um, one thing I didn't notice, uh, beyond hey, we're re-comparing every single time, with the square root and all that, is what if I did this instead of x y coordinates? What if I did like 10,000 dimensions instead, like x1 to x 10,000, right? Um, it gets a bit costly, right?
Right.
Even if you were doing the map where you did the distance and pair, you're still copying the distance or the pair each time. One thing I would note instead would do think about like the size efficiency and say, hey, instead of that, let's just keep the distance and maybe the index of where the original point is. So, um, at this point, I'm kind of nitpicking because you actually did really well. I would definitely move you on to the next round. So, nice job.
Okay. Thank you so much.
Anything you want to comment on? Any questions you have?
I was just wondering if you want to tell me what company you work for.
Right now, I guess I don't. I was at Microsoft last week, but I'm switching up jobs, so I'm kind of in the interim vacation right now. So,
Oh,
uh, I've worked at Google and Microsoft before this.
yeah,
So,
what'd you do specifically? I have a couple of on-sites coming up. That's why I'm on this platform studying.
sure. So at Google, I worked on YouTube's enforcement team. I was responsible for taking down spam videos and any any video that was flagged that wasn't hold on, that wasn't content related. So um, stuff like DCMAs did not go through us, but like porn and spam and anything else like harassment and stuff did. I dealt with the machine learning side of that. At Microsoft, I worked on SharePoint, some of the networking stuff and like the development infrastructure. So more of hey, let's build tools for other devs to do their work.
Okay, that's cool. I was just curious.
Oh yeah, no, yeah. Now I'm going somewhere else. So now I'm in a quick vacation. A
Okay.
vacation that apparently I decided I was going to be sick during.
Oh, okay. I just recently got out of the plague, so I understand.
Yeah. Any other questions?
No, I think I'm good.
Awesome. I think you did well enough to obviously make it on site. And I think if you were doing it on site with me at your level, I might say you were a week higher. So, and hey, yeah, let's move them forward to the hiring committee. So, there are a couple things that I was nitpicking on. If you did well in that, I would be much stronger of a hire. Just I didn't see it just quite yet. So,
Yeah, I'll take a look at that stuff.
yeah. And you're able to rewatch it and everything and see what you did. So,
Oh,
cool. Anyway, if you don't have any other questions, I'm gonna jump off. Write your feedback. It'll be along the same lines, but you can review it later as well. So, um, besides that, I wish you the best of luck on your own sites.
yeah, thank you for your time. You have a good one.
Yeah, you too. Bye.